Good morning, friends. Myself, I am Hardev. Today we have studied the today we have studied the hydraulic turbine unit number 5. In that we study the velocity diagram of Pelton wheel turbine and formulae. So let's start. So this is a required velocity diagram. The bucket of shape is hemispherical. So the bucket of shape is hemispherical. Hence, the inlet triangle having no diagram. So in this ABC U1 V1. U1 is a blade inlet velocity, V1 is the initial velocity. VR1 is a VR1 is a relative velocity, VW1 is a inlet over velocity, and F2 is a flow velocity at outlet. Similarly, VF2 relative velocity at outlet. So U2 and VW2 in this U2 blade velocity and VW2 is a whirl velocity at outlet. So let's draw the diagram first. So whenever water coming from turbine and impact on blade, so it impact on splitter at V1 velocity at U1. So it not having inlet vane and jet angle. But when it impact on blade, it gives some direction which is shown in figure and create an angle vf2 v2, so phi and beta, so u2 vw2, this is a required angle. So in this, firstly draw the angle. Draw the diagram carefully. डायग्राम झाली की मला सांगा. पटकन ड्रॉ करा डायग्राम. व्हॉट इज अ डायग्राम? So inlet triangle directly impact on splitter, so root of the blade, so inlet triangle cannot be created. So in this inlet triangle and outlet triangle, there is a only outlet triangle which is shown in figure. Alpha and alpha is 0, beta is outlet jet angle, theta is a inlet vane angle, phi is a outlet vane angle. So V2, VW2, VF2, VW2, U2, this is a outlet velocity of a triangle. So let see the derivations. So H is a net head acting on Pelton wheel. So H is equal to Hg minus Hf. Hg is a gross head. Hf is Darcy's friction factor 4 FLV square upon 2GD. So where D is the diameter of penstock, N is the speed of wheel in RPM. Where D is the diameter of wheel, small d is the diameter of jet. So let V1 velocity of jet at inlet is equal to root 2GH. So U is equal to U1 is equal to U2. Let similar angle pi dn upon 60. So let's see the velocity triangle will be straight line. So VR1 is equal to V1 minus VU. So V1 minus U1. So V1 minus U. VW1 is equal to V1 because alpha and theta is 0 as shown in figure. So firstly write down this. लिहून झाला असेल तर सांगा मला. So let's see the next. From velocity triangle at outlet, we have VR2 is equal to VR1. So VW2 is equal to VR2 cos, in that with the help of trigonometry cos phi is equal to VW2 plus U2 upon VR2. So with the help of that we can calculate the VR2. Let's see the force exerted by jet. So by the jet on water in the direction of motion is given by F is equal to mass into velocity, momentum. That is a mass into initial velocity minus final velocity. So Fx is equal to rho a V1, that is a mass, VW1 plus VW2. So in this way, beta is an acute angle. So negative sign will be taken. So in case of when the mass striking is rho a V1 is equal to rho a VR1. So with the help of that equation, the area of jet is given by pi by 4 d square. So the net work done is Fx into U, that is a force into displacement. So rho a V1 VW1 plus VW2. So let's write down this. So let's see the work done. That is, Fx is equal to rho a v1 vw1 plus vw2 into u. So the power given by runner is mass into velocity into u in kilowatt. So rho a v1 vw1 plus vw2 into u divided by 1000, that is in kilowatt. So work done per unit weight, that means per unit weight is rho a v1 vw1 plus vw2 into u per weight. So weight is equal to mg. So mass rho a v into g. So rho a v1 upon vw1 plus vw2 into u. With the help of that equation, rho a v1 to g is equal to 1 upon g vw1 plus vw2 into u. So in with the help of that equation, we can see the work done per unit weight. Next, the energy of inlet in the form of kinetic energy is equal to half mv square. So this is required half mv square. So but kinetic energy is half rho a v1 into v1 square. So with the help of that, this is the kinetic energy and work done formula. Write down these lines. Work done is output, kinetic energy is the input. So it is a depend on, it is required for efficiency of turbines. So next is a hydraulic efficiency. So what is a hydraulic efficiency? So it is a efficiency is a output upon input. So work done, hydraulic efficiency is defined as work done per unit kinetic energy. So the work done is rho a v1 vw1 plus vw2 into u. So half rho a v1 into v1 square. So that is with the value 2 into vw1 plus vw2 into u upon v1 square. So in that, vw1 is v1, vr1 is equal to v minus vu. So with the help of that, vw2 is a vr2 minus cos phi minus u. So put in the equation vr1 and vw1 and vw2. So that is a v1 plus u1 minus v1 minus u cos phi minus u into u. So with the help of that, the formula for efficiency is 2 v1 minus u 1 plus cos pi u upon v square. So with the help of that, we can calculate these. We can calculate the efficiency and formula. So write down this. So next is maximum efficiency. So put in this equation, we can put v u1 u is equal to v1 by 2. So with after calculating this equation, the maximum efficiency is 1 plus cos y upon 2, as shown in figure. So with the help of that, first is u is equal to v1 by 2. So put in the 2 into v1 minus u by 2 into 1 plus cos phi v1 upon 2 v1 square. So 2 into v1 by 2, 1 plus cos phi v1 by 2 v1 square. So in this way 1 plus cos phi upon 2. So write down, this is the formula for maximum efficiency. So in this way we completed the velocity diagram. In next lecture we see the example.